My name's Tim McConnell. I run engineering for 3D Robotics. My office is in San Diego. We do all of our engineering and design work there, and we're actually just a couple miles from the border, and I'm over across the border on a regular basis to Tijuana, where we do all of our manufacturing. We build flying robots. You can see one right there, which is, it's called Iris. It's a quadcopter. It's got 4 motors and 4 propellers, and it's a consumer-based drone or UAV or unmanned aerial system or many names that go by it, but basically it's a flying robot that flies by itself. You see it flying on its own, but yes, Kirk, you can actually attach a GoPro camera to the bottom of that and fly around and get great aerial footage, and I'll show you a little bit of video showing you the capabilities of the system. So not so much involved in the IT space. We're not quite as interesting. We just, make flying things. But it's something that we have a lot of fun with. I've got a 25-year career, and none of my kids could ever have told you what I actually did for a living. But when I took this job a year ago, my daughter texted me from college and said, "Dad, all my friends think you're cool." So that to me is the pinnacle of success. So I'll just give you a little bit of the history of the company, how we got here and where we started. As Kirk said, we were founded by a couple of guys. Chris Anderson, the editor-in-chief of Wired Magazine, who lives up in Berkeley, and Jordi Munoz, who grew up in Ensenada and Tijuana, and now lives in San Diego and works with me in the office there. So 7 years ago, Chris started putting together some ideas for how could he take a Lego Mindstorms and make a plane fly with it. And he put together the first Lego drone, which now hangs in the Lego Museum in Denmark. Jordi Munoz, on the other hand, was living in Riverside, California, waiting to get his green card authorization, so he really couldn't work and was trying to find something interesting to do. He took a Wii controller and took it apart and started pulling out the sensors and thought, what if I put some of these sensors on a remote-controlled vehicle? I could have it control itself. So he really created the first electronic system for autonomous control of a consumer vehicle. Chris had built a website called DIY Drones, where people who are interested in developing these technologies could share stories and collaborate. Jordi posted some videos of what he had done on DIY drones, and Chris saw them and said, I need to get to know this guy. So he called up Jordi and said, Jordi, what do you need? Jordi said, money. So Chris gave him $500 and said, here, why don't you start with this and we'll see where we can go with it. Jordi put together a little system for fabricating some electronics, began providing them to people in the DIY drones community, and it just took off from there. So the two of them got together and formed 3D Robotics, and it's really been a great success story since then. It's been growing about 100% a year for the past several years. Started out with manufacturing in a facility there in San Diego. That grew very quickly, and that's when they realized that we really should move this down to Tijuana. There's so many advantages for the cross-border fabrication. So Jordi called up one of his high school buddies, Guillermo Romero, who had some great experience in doing manufacturing, and said, we need to build a factory to create these things. The autopilot is the brains of all of the things that we make. All of our flying robots and even some cars as well all use this same autopilot technology. The one that we sell now is called a Pixhawk. It started out as an Arduino development about 5 years ago and has expanded in its capabilities over time. So it's now a 32-bit processor that's completely responsible for flying the plane so that humans don't have to be involved. It doesn't require any remote control. You can just give it commands from your mobile device and it will fly itself. The software is actually developed by an open source community. It's a very interesting model that allows for a lot of people to get involved in the software development and for very rapid collaboration. And then we've just recently released something called Drone Share, which is a way of taking all of the data that people generate from their flights and share them in a repository in the cloud so that people can look at other people's flights and flight data and learn a lot from what people have done. So the thing we're all here to talk about, of course, is how do we collaborate between what we're doing in the US and things here in Mexico and Latin America. And I really liked what Kirk said about cultural fluency. It's something I've learned a lot in the year that I've been at 3D Robotics. As I said, I'm back and forth between San Diego and Tijuana a lot. Made a whole bunch of great friends already in the Tijuana area. And I found that it's so easy to be able to communicate and interact with the folks there. So we get really great engineering talent down there. There's some terrific universities right there in the Tijuana area, as well as folks at University of California in San Diego. So we've got engineers on both sides and engineers educated on both sides. And there's a lot of experience locally from both the city of San Diego and the city of Tijuana that encourages this type of collaboration and that really helps people out with supporting the interactions and supporting the business relationship. This is a chart that I like to show people when they say, we should do our manufacturing in China or we should outsource things to China. You realize there's really not, in my mind, any significant advantage going to China. There used to be an advantage with salaries because they were much lower down here, but you see, they've really evened out pretty well to where you're not getting a salary advantage. You've got the disadvantage of a great deal of distance, time getting back and forth. There's a huge cultural gap that I haven't figured out how to get across. So just to give you a little more detail, because I like to show off the fun stuff that we do. We'll talk about some of the things that we build at 3D Robotics and what they work for. So most of what we build are copters. This is the Iris that you've seen. This is an X8 because it's shaped like an X, and it has 8 pairs of motors and propellers. This is called a Y6. You can figure out why. And then we also make fixed-wing airplanes, and they have different sort of uses for each of those things. The beauty of a multi-copter is that you can do vertical takeoff and landing. You can hover in a particular position for as long as you want. Fixed-wing, on the other hand, is great for longer missions where you want to fly great distances for mapping or for inspecting large areas. So this is a video showing our Follow Me capability. So this is just an example of why you don't need to be an expert at flying things. So Brandon has just taken his phone and he's hiding it in his shorts so he can go running, and the robot's just going to follow him and video him while he's running. No one's controlling it, no one's paying any attention to what it's doing, and he's going to come back from that with really nice video of him running. You can take it out with you biking and all sorts of applications, windsurfing, snowboarding. Here it's following this boat. There it's following one of my colleagues on a bike. And the beauty of the open source development is that we can create applications like this very quickly. Follow Me was invented after we started shipping Iris, but everyone who has an Iris can download all the code, get the application on their mobile tablet or phone, and be able to do this Follow Me capability with their copters without having to be any sort of expert at flying things. Right now, people are using drones in Africa to track rhino poachers and to track the movements of rhinos to be able to try to protect those populations. And there's just a huge number of other things that you can do with these things. If you can imagine the beauty of getting a small camera out there for low cost, quick response to environmental issues, helping out with construction, mapping progress there. So I'll talk a little bit more about enterprise applications. If you look at this picture here, it's a picture of someone's crops that's taken with NDVI indexing. So instead of just taking visual pictures, it's called a normalized differentiation vegetation index. And it's a way of comparing the visual spectrum with the IR spectrum, and it can give you a great deal of information about the health of your crops. So you can go and fly a drone over your crops every single day, get this data about how the crops are doing, and get really precise information about what types of things the farmer could be doing to improve the functionality of those crops. 3D mapping is a great application for this. If you can fly around a building, for example, and take lots of pictures. So this is the Fry's electronics store in San Jose, California. You can see it's got the kind of Aztec theme there. We took a bunch of pictures with a drone and created this. This is not actually a photograph, it's a 3D map that we made based on pictures. There's a different look at that same 3D map. So you get these wonderful pictures and views of things that are really valuable to people in the construction industry, which is just behind agriculture as the second largest industry in the world. And it's not just bridges. There's all sorts of infrastructure in the US. There are 2 million miles of pipeline, 140,000 miles of railroad track, 2.7 million miles of high voltage power lines. Just in San Diego, there's 26,000 miles of these lines going through 500,000 trees. And San Diego Gas and Electric has 4 manned helicopters that fly all day, every day, inspecting power lines. Each of those helicopters costs about $1,500 an hour to operate. So if you do the math there, they're spending a lot of money inspecting power lines. And it's a dangerous occupation. People don't like having the helicopters flying overhead. So how can we do it more efficiently? Well, you all know the answer. Let's do it with flying robots. So if I could get a robot to fly under a bridge and take all these pictures and video for me and analyze them, it's much safer, it's much cheaper, it's faster, you can do it every day, you can put robots anywhere. And of course, that's why we're building them. So we build these systems for being able to inspect infrastructure and for really advancing the technology of where this is going. Here's a nice picture that I just got. This was just a couple of weeks ago. This was the former director of technology for National Geographic magazine, and he's using a drone to take a selfie. We call it a droney, and he's down in a cenote in Mérida. So San Diego is a real center for robotic activity. These are some of the bigger companies that are all involved in development of robots there. Qualcomm has developed a new chipset called Snapdragon, which is designed initially for phones, but you find that almost all of the things that you want to do in a cell phone are the same things that you want to do with a robot. You want to know what angle you're holding it at, you want to know where it is with GPS, you want to know how fast it's moving. So the beauty for us in the robot industry is that we don't have to develop all this technology. The companies like Qualcomm and Nokia are developing it all for us, and we can just put it into robots.
Is there television producers now using drones?
So that's a great question. One of the things that's really, at the moment, impeding the progress in the in commercial space is that in the United States, drone activity for commercial use is currently forbidden without special exemptions. The FAA, Federal Aviation Administration organization, is being very careful about allowing people to fly drones because, you know, there are safety issues associated with it. So there's a very small number of organizations in the US right now that have authorization to use drones. There is a group of movie producers that have gotten together in a consortium and have gotten an exemption, so there will be some movie studios that will be using them shortly. However, the US is more strict than some other countries, and probably none of you would have noticed, but if you went back and looked at some tapes from the Winter Olympics in Sochi last year, you would see all the time, I noticed it every time, shadows of quadcopters flying by. You know, I would sit with my wife and say, hey look, there's a shadow of a drone going by. So there's a lot of things that are being done for television worldwide, just not in the US yet. In fact, Mexico is more permissive than the US, so that's another advantage for us being on the border is we can drive across and do some of our testing without having to worry about restrictions as much.
Can they function as sort of endpoints on a network so that I could see real-time video or real-time IR and process it through a bigger computer than you have on board?
So there are lots of things that are being developed. Right now, the things that we sell on the website will actually capture video on an SD card, which you then download, but I can't really give away any secrets, but stay tuned in the very near future for video that will be, you know, coming live from the robots. In addition to that, there will be much more intelligence being placed on the robots, so not only being able to stream video live, but being able to process that video and make intelligent decisions based on what the robot sees. So instead of flying a set course, to be able to say, go to this point, take some video, and then make the decision about where you want to go next based on what you've seen.
Can they network with each other so you could fly a squadron of them to do a certain application?
Theoretically, yes, and there's some work being done at universities. There's a lot of complexity there, not just with the networking, but with having things flying close to each other. There's what's called sense and avoid technology that's really needs more development before it's really in the mainstream, but to be able to avoid obstacles. Another thing that they need to get better at is seeing things and knowing to fly around them. Right now, we generally just try to keep them high enough so they're above trees and power lines, but it won't be long before they can avoid each other, know where each other are, avoid obstacles and things like that. So lots of very fast development in those areas.
But what things do we don't even imagine drones can do? I mean, mining applications or I don't know what. Okay, what's the future?
Well, that's a wonderful question. You know, we spend a lot of time just having fun amongst ourselves, trying to think about what are the near-term things. But one of the most beautiful things about this development community we have and all the people that are involved is there are a lot of people coming up with ideas that I never would have thought of. In general, the rule for robots is anything that falls under the category of the 3 Ds. Dull, dirty, and dangerous. You know, if there's any of those you don't want people in any of those positions. You don't want people doing repetitive actions. You don't want people doing things that are, you know, horribly dirty or getting themselves covered with stuff and being in dangerous situations. So any situation like that. But the things that we're focused on is agriculture is the closest in thing. Inspection of large areas, so railroads and pipelines and things. We're doing some testing right now with being able to inspect facilities such as, if you picture like an oil refinery or something, where you want to know, is there anything dangerous happening up amongst the smokestacks or places that are hard to get to be able to fly around places like that. Any type of security application. But then you could sit here, you and I could sit over a pitcher of beer and think of a lot of other great ideas too.
There was a lot of excitement when Jeff Bezos went on 60 Minutes about a year ago and said, we are already looking at the day when we can use drones for delivery. There are some who are very skeptical about that. Where do you guys stand?
So it's a great question. I love Jeff Bezos. If you remember, it was actually the first week of December that he had that interview on 60 Minutes. And I personally think that it's way farther out than he said it was, but he had everyone in the country talking about Amazon 3 weeks before Christmas. The guy's a genius, you know. There are a lot of interesting areas for development as far as delivery of things and what you would want to do and what you wouldn't want to do and what can be done. You know, in the video that they showed, they had a nice little package being brought down in someone's, you know, front sidewalk and the guy going out and picking it up. I don't picture anything like that happening for a really long time for a number of reasons. One, you know, anyone who has pets or little kids that would be playing in their front yard will think, I'm not sure I want this thing with these fast spinning blades coming down right next to where my kid is and delivering packages. On the other hand, Google just did a great demonstration a few weeks ago in Australia of medicine delivery to a remote location. And they had a copter that went and hovered over someone and basically lowered down a tether that had some medicine on it and gave it to a farmer and flew away. Things like that are very close to being able to be done right now. So you just have to think about what's practical, what's going to be legal, what's safe, you know, and how can those things really be done. But you'll be seeing a lot more of these things in the commercial and consumer space over the next few years. Delivery of things is definitely a good one. Oh, there's another one. Let me just point out. There's a great competition in Australia called the Outback Challenge, and it's a drone competition where the goal is to have a drone fly out, find a lost hiker, and deliver some supplies to that hiker. And one of our developers who lives in Canberra won that competition. It's a $50,000 award to be able to find this dummy called Outback Joe and deliver some food and some water. So that's a great use for delivery.
Neat. All right, very good. Well, great job, Tim. Thank you so much.
Thank you all.